All right, so everybody should have a syllabus in front of them. We'll spend a little time sort of just looking at some highlights from the syllabus before we jump into our first math lesson. So this is college algebra. We're section C. Clearly, you all know when and where we meet. I have my office and studio hours listed here. And then the required materials. Okay, so this is the first maybe confusing piece on the syllabus. The only thing you need to buy, right, is a MyMathLab access code. Okay, so it's just like a little folder. Does anybody bring one with them? Yeah, like this. MyMathLab Student Access Kit. So you can buy it in the bookstore, right? It's just this little folder, or you can buy it directly through Pearson. The link is up there. If you're using financial aid, you do have to go through the bookstore, but if you're not, buy it through Pearson and it saves you a good amount of money. I think it's just under $100 through Pearson versus the bookstore, which is like $130 or something like that. So that access code gives you access to MyMathLab, which has a complete version of the textbook on it, an electronic version. So that's the only thing that you need to buy in terms of a textbook. Okay. Then you're going to need a scientific calculator. They're like $10 to $20 at Staples or whatever. And then optionally, you can buy an actual physical textbook if you want a printed out version on paper. You can either buy a hardcover or the 3-ring punched version. It's only if you just like hate reading off a computer screen, or I don't know, you want to be able to take it with you wherever. It's just optional. And then you will need access to some graphing technology, whether you're in class or at home. And that could mean software on a tablet or a laptop. There's several free things that can work really great. Or you could buy a graphing calculator, or maybe you have one from a previous class. You can use that too. Okay, so we're going to talk about what the course is in a few minutes, so we'll skip over that for now. So what to expect in class? We don't have much time in terms of how much the material we need to cover to spend asking questions about the previous class. So if you have questions, come to class or the math studio early. I'm free from 12 to 1. I'm just like eating my lunch, so if you have questions, just stop by my office. It's no problem. So the way class runs is it will usually start with a set of preview questions based on the assigned textbook reading. You'll come into class, you'll sit down, and you'll just start working on the preview questions. Okay, so you won't, it'll just be the same every day. You have the preview questions as part of this big packet that I just gave you. So you see on this first page, the first thing is preview exercises. Okay, so when you come in, you'll just start working on those. We may or may not go over them together depending on how everybody does with it. And then I will lecture on new material. From 15 to 25 minutes will be the lecture period. And then for the remainder of the class, you'll be working on problems, either individually or in your groups. And I will be circulating, and if you have questions, ask each other, ask me. And that's how class runs. Okay. At the end of class, you'll have a homework assignment and a reading assignment. For each class, and this is a general rule of like all accredited schools, for each class that you're taking, you should expect to spend about 2 hours outside of class completing homework and doing reading for every hour you spend in class. It's just a good thing to know when you're trying to think about how much time you need and to schedule and how much time you'll still have free. Okay, so attendance is really important, and the way I take attendance is that on each table there's a folder here, and so there's 5 seats at a table and there are 5 blank grids here. You put your name above one of the grids, and each class when you come in, just put a check mark next to the date. So it's self-reported attendance. And if you do have to miss a class, it's your responsibility to make up whatever you missed. Moodle is a great resource if you have to miss something. So this is our Moodle site. We're sharing it with 2 other sections of college algebra. So we're section C. So if you go into syllabus and other documents, you can see section C. These are the things I've given you so far, right? The syllabus and the MyMathLab registration instructions. And then everything else will be the same for all 3 sections. I have a YouTube playlist of class videos, so that's what I'm recording everything I say right now. And it records what I say with what's happening on the board. So you can watch that as a video if you ever miss class. And then in addition to that, you can also click on, there'll be another version of this packet 1, but it'll say annotated, and that'll have all the class notes on it too. So you have a video plus the static notes. So since I have this open, other resources are, we're having take-home quizzes this semester. So each time we have a take-home quiz, I'll post it here on the day that I hand it out. So if you lose it, you will have access to an electronic copy. If you're absent the day I hand it out, you'll have access to an electronic copy. And when we talk about quizzes more, I will remind you again, but the quiz due date is the quiz due date no matter what. Okay, so if you are sick, you email me an electronic copy of your work. And then projects are posted here. And then the last block is test prep material. There are videos of sample questions for when you, and I'll show this to you again when we get close to the first test. Yeah. That's what these are. These are videos of solutions. Yeah, and the practice problems are in the back of the packet I just gave you. Yeah. All right, so we'll jump back to the syllabus and looking at resources. So we just talked a lot about Moodle, right? Home base for our course, all kinds of resources in Moodle. But your main 2 resources are going to be me and each other. Okay, so you can talk to me, email me anytime. I do have an automatic response in my email right now that says that I might not write you back outside of my regular office hours because there's some contentious contract negotiations right now, and so a lot of faculty we're on what's called work to rule, like don't do anything extra. But I will write you back. It's more like of a statement than a practice. So you'll get this response, but no, I will write you back. So the Math Studio right across the hall, it's staffed all day by GCC math instructors. It's a great resource. If you want just a place to sit and do your homework, there's several computers in the corner so you can work in there. And everyone who works in there will be able to answer your questions. The peer tutors, also a great resource. Just call and make an appointment. It's free. Smart Thinking is online tutoring. It's available 24 hours a day and 7 days a week. So if you're studying the night before a test, you can get a question answered in the middle of the night if you need to. YouTube, there's a link to a playlist of all my course videos. It's posted in Moodle. And if you want to browse all my videos, you can browse my channel if you want. And then I've got MyMathLab tech support and GCC tech support if you ever get stuck. If you need or think you need some kind of accommodation, just let me know and we will get that worked out. Your grade is going to be based on homework, and all homework is going to be done in MyMathLab, or should be submitted in MyMathLab. But you should still keep a notebook with a record of all your work and answers. There's a couple of reasons for that. One, if you need help, you can show a classmate or me or a peer tutor what you tried, and they can try to find your mistake. And also, and though it's never happened, and I've been using MyMathLab for like 4 years now, and it's never happened that somebody's work has disappeared. But if that ever happened, you would have a notebook full of all your work, and I could see that you did your homework, and we'd get it figured out. Okay, so homework due dates are all posted in MyMathLab, and you can seek help from anyone you want for homework. And I'll drop 5 low homework grades at the end of the semester. So you can miss up to 5 assignments without penalty. And homework can be submitted late. You just have a 10% penalty on the unfinished, the late portion of the assignment. So since we're here talking about homework, I think I'll pull up MyMathLab, give you a little preview of what it looks like. Okay. Several of you have probably used this in a previous course. If you haven't, I'm just going to give you a quick intro. This is the main site where you log in. If you have an account because you've used it for another course, you can just click sign in. If you've never used it before, click student to register. All right, so I'm going to click sign in. All right, so once you're signed in, all the courses that you're doing in MyMathLab will show up on the left. It most likely will be just this class, right? Even if you've taken a previous class that uses MyMathLab, it will have expired, and so it won't show anymore. But so you'll click Math 107C, that's us. And so this is the main course page. Okay, it shows you some upcoming assignments, and you have sort of a results, how to keep track of how you're doing over on the right. There's a calendar, little blue dots are sort of important dates. Your first due date for homework is going to be February 3rd. There's going to be 4 assignments due. I wanted to give you a week to sort of make sure you could get registered in MyMathLab, get all the kinks worked out before your first assignments were due. All right, so along the left here are several menus. If you click chapter contents, this is how you get to the textbook. Right, so if you just click table of contents, a new tab opens, and I don't have Adobe Flash on this computer. So, go away. I think if I do it in Google Chrome, it'll work, but that's how you get to it. So that's also a good tip. If you have trouble, try a different browser. Firefox and Google Chrome seem to work the best. So that's how you get to the textbook, and then I'm going to go back to the main menu here, and multimedia library is also really cool because the textbook provides all kinds of cool things for every chapter and section. Like let's look at chapter 1, all sections. We'll see what they've got. Is it doing it? Find. There we go. All right, so there are like animations, there are videos that you can watch about each section that are not me, they're written by the publisher, but it's always good to have a second voice. And then there are PowerPoint slides, so it's just a nice extra resources that you can look at. But the main thing you're going to use MyMathLab for is homework. So you click the homework button, and it gives you a list of all the homework for the whole semester with their due dates on the left. So this is where you're mostly going to go to see what homework is due when. And when you are ready to do a homework, you just click on the name of it, click on question, pops up in a new window, and it asks you a question, and you type in the answer. What is -12 to the 0 power? 1. Anything to the 0 power is 1, so I'm just going to answer it and show you what happens. Let's answer it wrong first, just to see. So we'll check. Nope, that's not right. And they remind you, they say, remember, 0 exponents? Anything to the 0 is 1? And you go, oh, yeah, that's right. I remember that. You go back and you fix it. Check answer, and it tells you you got it right. And it keeps track of your questions on the page that we were just on. So now behind here, see next to question 1, you got a little green check mark because you got it right. So you've got a week to sort of play around in here and get acclimated, and then you've got a bunch of assignments due. Your grade book tells you this is strictly just for homework, right? This grade book. And right now, for me, I have a 1 out of 16 on the first assignment because I just did one question. All right, so that's it for MyMathLab. I handed out a 1-page sheet for how to register in MyMathLab. Okay, so you'll get, if you have any trouble with this, just let me know and I'll walk you through it. All right, so that's homework. Projects, there's going to be about 4 projects over the course of the semester. The due dates are in the calendar at the end of the syllabus, and they'll involve in exploring concepts and tools in more depth than the homework problems. There'll be 4 take-home quizzes this semester. Sorry, that's not for our class. I'll bring it over in a second. There'll be 4 take-home quizzes. Take-home quizzes, for each one, I'll announce what resources you're allowed to use. And since there are only 4, I won't be dropping any. And then exams, there'll be 3 in-class exams. And then there's a 2-hour final exam. Who else came in late? Okay. For makeups, oh, and before for tests, you're only allowed to use a scientific calculator. So if you generally use a graphing calculator, I will lend you a scientific calculator for tests. All right, so the makeup policy. Take-home quizzes are never accepted late. Okay, if you're ill, you can email your quiz to me. If you were ill the day I handed it out, you can download it off Moodle. Homework you can hand in late, but it gets a 10% penalty on the unfinished portion of the assignment, whatever part was late. Projects are never accepted late. If you're ill, you can email your project to me. In general, makeup tests aren't given. If you miss a test, you'll normally receive a 0 on it. Of course, we can work something out if you were really sick or there was some kind of hazardous weather condition or whatever. But you need to contact me as soon as possible. Let me know what's going on. And I reserve the right to ask you for some kind of documentation of that extraordinary circumstance. All right, so for your grade, I'll calculate your grade 2 different ways and give you the better of the 2. Okay, so one of them is test heavy. We have the largest percentage is on your exams, 60% exams, 20% final exam. Whereas test light reduces the weight on exams and distributes it a little bit more throughout homework and projects and things you do at home. So you don't have to choose. I'll just calculate it both ways and give you the better grade. All right, then you have a tentative course schedule. We'll stick to this pretty closely unless there's a snow day or something, in which case I will print you a new one. Okay. All right, questions on the syllabus, how the course runs, anything like that? Yes. Yeah. To your tests. Yes, you can. Yes, for every test, you will be allowed to bring 1 page of notes with you to your test that you write yourself. Yes. Yeah. Correct. Yeah, you just put the answer in. Oh yeah, no, you just put the answer in, and it's really good practice to have your work written out, but I'm not going to check it. Right, yeah. Yeah. All right, so first things that are happening here, we're going to do a little bit of a course introduction and an algebra review. And then the first assessment thing that's going to happen is that I'm going to give you project 1. I'll actually give it to you today. It's not due until February 5th. And then your first quiz, your first take-home quiz, I'll give you on the 8th, and it'll be due the 10th. So you can see stuff due is in this last column here. And quizzes are pretty much in bold. That's the day I'll give it to you, and it's due the next class. All right. So I'm going to have you jump to your preview exercises. Normally you would have done this before I did any talking. So pretend that you just walked into class and you sit down and you start your preview exercises. All right, so I can see everybody's working really well. I love it. I'm going to stop you, interrupt you. I do have the answers up here, and I've gotten some feedback of things that lots of people wanted to go over. So I'm thinking number 1 we'll talk about together. Number 3, 6, and 8. Anybody else have a request? Something that stumped them? Yeah, I got 6, yeah. All right, so let's look at 1, x cubed times x to the 4th. So x cubed times x to the 4th. I think most people actually got this, but I do want to remind you, because several tables were talking about how do you add them or do you multiply them, right? So it helps to help you remember the rule to think about what exponents mean, right? What does x cubed mean? 3x's, x times x times x, yeah. So x cubed means x times x times x, right? And then x to the 4th is 4x's multiplied together. So x times x times x times x. So that's x cubed, that's x to the 4th. When I write them all out, how many x's did I write down? 7. So this is x to the 7th. Okay. So if you ever forget the rule, you can just make up a little simple problem and be like, oh yeah, okay, so it must be adding, right? Because 3 plus 4 gives you the 7. All right, number 3 was 2 root 12, 21 root 2 plus 10 root 2. 21 root 2 plus 10 root 2s. This is combining like terms. So if I wrote 21x plus 10x, what would the answer be? 31x. It works the same when you have a radical. This is 21 copies of root 2 added together plus 10 copies of root 2 added together. So that makes a total of 31 copies of root 2. Right? So again, 21 times square root of 2. Multiplication just means repeated addition, right? So this means take root 2 and add it to itself 21 times. Right? And then I'm going to add 10 more root 2's. So I have root 2 plus 10 more of them. So then I will have written down a total of 31 copies of root 2 and added them all together. So that means I have 31 times root 2. All right, number 6, 2/7 to the 0 minus 32 to the negative 2/5. I know, I think I have to orient it because it's touching things when it's not supposed to. All right, so what's one thing we could do here? What's one thing you know? 2/7 to the 0 is 1. Okay, so in my next line, I'm going to replace 2/7 to the 0 with a 1, and I'm going to copy everything else. Okay. Anything, no matter what it is, raised to the 0 is 1. All right, what's the rule about negative exponents? How do you deal with negative exponents? Flip them. Yep. Okay, so when you have something raised to a negative exponent, this becomes 1 minus. And this is, for some of you, depending on who you had in a previous class, you might have heard this crying baby analogy, right? A negative exponent is like a baby that's crying, right? So sometimes when babies are crying is because they just woke up from their nap and they want you to pick them up, right? And sometimes when they're crying is because they're tired and you have to put them down for their nap, right? So this baby, 32 to the negative 2/5, it's crying. We have to move it down, put it down for its nap, right, to make it happy. So we move it to the denominator and we make the exponent positive, right? So now the baby's not crying, right? And then what's left in the top when you move that down? A 1, good. All right, so now we got to deal with the 32 to the 2/5. When you have a fraction that's an exponent, the top and the bottom of the exponent, the 2 and the 5, play different roles. What does the 2 do and what does the 5 do? Yeah, the number on the bottom is the root and the number on top is the power. Okay, so I'm just going to rewrite this as, this is 32 fifth root raised to the second power. And you can do it in either order. You could square it first and then fifth root it, or you could fifth root it and then square it. Doesn't matter. I'm going to fifth root it first because I can take the fifth root of 32 in my head. So I need a number that when you multiply it times itself 5 times, you get 32. 2, yeah. 2 times 2 times 2 times 2 times 2 is 32. So this becomes 1 minus 1 over 2 squared. And what's 2 squared? 4. So this is 1 minus 1/4, which is 3/4. So that one reviewed a lot of rules. A good one. All right, let's see what else we got here. 8. Root 50 times root 6. Am I allowed to just do this? 50 times 6? Yeah, I am. Yeah. Yeah, when you have numbers under a radical, you can just multiply them. Yeah. We'll do it 2 ways, and then you'll see that they come out the same. Okay. So at root 300, now if I want to simplify that, are there any perfect square numbers that divide into 300? Perfect square numbers. 10's not a perfect square. 100. Yeah, I think you're thinking 100. So I could rewrite 300 as 100 times 3. Break that into 2 square roots. And then the square root of 100 is 10. And square root 3 can't be simplified, so you just get 10 square root 3. Another way you could do this is to simplify each radical separately, right, and then multiply. So the square root of 50, I could rewrite as the square root of 25 times the square root of 2. And square root of 6, it doesn't have any perfect square factors, so it just stays square root 6. Square root of 25 is 5. The square root of 2 times the square root of 6 is the square root of 12. So multiply them together. And then does 12 have any perfect square? 4, yep. is a perfect square factor. So I could rewrite 12 as 5 times the square root of 4 times 3. The square root of 4 is 2. The 3 you can't simplify, it stays under the radical, and you end up with 10 root 3. I kind of like the first one better, but they come out the same. So you can do whichever one you want. All right, so we went over a few of those. I have a few more examples we can do together, and then if there's still time, we have some activities for you to work on. Some more problems for you to try. So after the preview exercises, which we normally won't spend as much time on as we did today, but after you come in, you sit down, you work on the preview exercises, this is the teaching demo part. This is where I lecture. Okay. So I have a few problems, and hopefully now that we've gone over some of the preview exercises, these rules will be coming back to you as we go through these. Okay, so if I want to raise all of this stuff in parentheses to the 1/3 power, that means that I have to raise every single thing in that parenthesis to the 1/3 power. I can't for today, but I can try to play around with it for another class. But it's static for right now. Yeah. It is on the packet. Yeah. 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 Okay, so because all of the stuff in parentheses here is just multiplication, that just means take every single thing in there and raise it to the 1/3 power. So this is 64 to the 1/3 times x to the 300 to the 1/3 times y to the 600 to the 1/3. All right, 64 to the 1/3 power. Remember, when your exponent is a fraction, the top is the power, the bottom is the root. So I'm looking for the cube root of 64. 4, very good. So that's 4. Okay. Here I'm raising a power to a power. When you raise a power to a power, what's the rule there? Multiply. You multiply them. Yeah. Yeah. So before you were trying to say one of them is multiply, one of them is add, right? This is the multiply one. So 300 times 1/3 is 100. And then same rule for the next one, y to the 600 to the 1/3. Multiply those powers, and I get y to the 200. That's another one. If you forget the rule, make up a little example for yourself, right? You say, well, what if I was just trying to do like x squared to the 4th, right? Do I add them or do I multiply them? Well, x squared to the 4th means x squared times x squared times x squared times x squared. And each x squared means x times x. So this is x times x times x times x times x times x times x. How many x's did I write down all together there? 8. So x to the 8th. Oh, it must be multiply. All right, 8 to the negative 2/3. The rules in here we talked about already. When you have a negative exponent, you flip it. So this becomes 8 to the positive 2/3, and you move it to the denominator. Numerator becomes a 1. And then the 3 is a root, the 2 is a power. So this is 1 over the cube root of 8 squared. What's the cube root of 8? 2. And when you square it, you get 4. All All right, 3 root 12 minus root 27. So as written, these are not like terms. You can't just add them together. If it was 3 root 12 minus root 12, then they'd be like terms, but they're not, right? So what I'm going to do is first I'm going to simplify both of these radicals, and I'm just going to do it like with my fingers crossed and hope I get some like terms. So root 12, how do I simplify that? 4 times 3, so this is going to be 3 times square root 4 times square root 3, because that makes square root 12. Okay, and then root 27, how would I break up 27 into a product of a perfect square and another number? 9 and 3. So this is root 9 times root 3. All right, the square root of 4 is 2. So this is 3 times 2, which is 6 root 3. And then the square root of 9 is 3, and the square root of 3 can't be simplified. So I have 6 root 3 minus 3 root 3. So I get 3 root 3. 6 root 3s minus 3 root 3s is 3 root 3s. Now those are like terms and you can subtract them. It's not root 2, it's just 2, because the square root of 4 is 2. Yeah, so 3 times 2 gives you 6. Yeah. And then this root 9 becomes a 3. All right, so factoring. We have not talked about factoring in the preview exercises, but it's another big skill that you learned in a previous class. Right, so 5x cubed minus 45x. Let's just look at the numbers first, 5 and 45. Do they have any factors in common? Any numbers that divide into both of them? 5. Okay, so I'm going to pull out a 5. And then x cubed and x. They both terms have at least one x in them, right? So I'm going to also pull out an x, pull out a 5x. All right, and then I've got a parenthesis opened. And what I put in this parenthesis is what I need to put in there, some stuff, so that when I distribute 5x to both terms, I get 5x cubed minus 45x. All right, so what do I multiply 5x by? Right, what do I put here so that when I distribute the 5x, I get 5x squared? Sorry, I mean 5x cubed. Squared. X squared. Okay, and then what do I multiply 5x by to make negative 45x? Minus 9. Great. Okay, so now I have 5x times x squared minus 9. There should be some bells flashing about x squared minus 9. They're both perfect squares. There is a difference of perfect squares, right? So this factors to 5x times x plus 3, x minus 3. Right, so the 5x I just copied from the previous line, and then x squared minus 9 factors, x plus 3, x minus 3. I would want it factored out completely, yeah. And you're right, I probably should have been more specific and written factor completely, yeah. Okay, so now that we've reviewed factoring, that's going to let us look at a fraction that has x's in it to try to reduce it to lowest terms. So anytime you're reducing a fraction, you're trying to cancel common factors. So can I do this? No, why not? Because they're separated by addition. Awesome. The x squared and the 3 and all the other pieces of the numerator, they're separated by addition and subtraction. You can only cancel stuff if they're separated by multiplication. Okay. That's why factoring is handy, because factoring means rewrite as multiplication. So x squared plus 3x minus 10. Can you factor that? Great. X plus 5, x minus 2. Good. So it's x squared. So then you can quickly multiply it out just to make sure it's right. We got x squared minus 2x plus 5x. That gives me the 3x. And then minus 10. And the denominator? Great. X plus 4, x minus 2. Do you have any factors that are identical on the top and the bottom? The x minus 2's. Now those I can cancel because they're separated from the things next to them by multiplication, which means you can cancel them. So now I've reduced this to x plus 5 over x plus 4. The x squared? It didn't go anywhere. Yeah. Yeah, so factoring means rewrite as a multiplication problem, right? So what I did is I took this x squared plus 3x minus 10 and I rewrote it as x plus 5, x minus 2. Because when you multiply those together, here's x and x, those give you the x squared back. All right, one more together, and then I'll give you a little bit of time to practice. When you add two fractions, what is the first thing you need to be able to add two fractions together? Common denominator. Do they have a common denominator? No, the two denominators are different. So to get a common denominator, we're going to build it. So I'm going to just rewrite my problem, but leave myself some space. And add some parentheses so that I don't get mixed up here. All right, so what is my common denominator going to be? X plus 2 times x minus 2. Once you have this written here, with like rewritten with a little bit of space, each fraction just looks at the other fractions and wants what the other fractions have in their denominator. Right, so this fraction has an x plus 2. It's looking at this other fraction and it's like, that guy's got an x minus 2 and I want one. So I'm going to put an x minus 2 in the denominator here. But if you just throw an x minus 2 in the denominator, you have to also put it in the numerator. Otherwise, you've changed the value of the fraction. So this is what we call a foo-foo, a fancy form of 1. X minus 2 over x minus 2 is just 1. So I have not changed the value of the fraction because I'm just multiplying by 1. A fancy form of 1. Now I go to my next fraction. It has an x minus 2. It looks at its neighbor. And it says, well, you've got an x minus 2. I already have one. I'm cool with that. But you have an x plus 2, and I would really like one of those. Right? So we add an x plus 2 to the denominator and to the numerator. And now both of my fractions have the same denominator. Okay? And when you have the same denominator, what's the rule for adding fractions? You got it. The denominator stays the same, and then you just add the numerator. The numerators. Okay, so my denominator is just going to be x plus 2, x minus 2. And then I have to add those across the top. I need like terms and stuff. So I'm just going to multiply first, right? Because the order of operations says multiply before add. So I'm going to multiply 3x times x minus 2, and I get 3x squared minus 6x. And then when I multiply x times x plus 2, I get x squared plus 2x. And now I can add like terms in the numerator. 3x squared plus x squared is 4x squared. Negative 6x plus 2x is negative 4x. Are we done? What else do we have to do? We should probably factor the numerator just to see if anything cancels, right? So we'll factor the numerator. They both have a 4 in it. They both have at least one x. So I'm going to pull out a 4x, and that leaves me with x minus 1. Do I have any identical factors in the top and the bottom? No, so now I am officially done. All right, so we just covered like a lot of material that's prerequisite stuff for this class. But each time we need to use one of these things, I will remind you of the rules, right? Like you don't have to be like perfectly in your brain, but you do have to know that they exist. And like when you watch me do it, if you can be like, oh yeah, that makes sense. I could probably do that if I practiced. You're probably okay. All right, so we only have 5 minutes, but you can work on some of this class activity, but before I have you start that, I just want to show you, after every set of class activities, there are the answers, so you can check your work as you go. And then there are your learning objectives. So you have homework. There's always preparation for class 2, or preparation for the next class, which is a reading assignment. And then you have an assignment in MyMathLab. And you need to complete the class activity. Okay, so you don't need to complete the class activity by next class or even the MyMathLab homework, right? So your first homeworks are due on class 4, which is February 3rd, I think. Okay. So you have a solid week to like work through all of this stuff. I'm going to be adding on to it. Yeah. Yeah. It's best to do it as you go. Yeah. All right. So that is, I think, a good intro for the class. This is the activity, but there's only a couple minutes left, but you can get a head start if you want. That's it.